Thank you. I'm Tim Panton. I'm CTO at Pipe. Total contrast with the previous talk, except that the topics are the same, and it's also there's a German link as well. So we're not so far off. But anyway, yeah. So I was thinking about this when I put this talk together. I was thinking about like how did I get into this, and it turns out that some 17 plus years ago, I did a two-factor authentication project here in London, managing Y2K rollout updates for financial information provider. And for me at that point, it had two totally new things, one of which was telephony, and the other one which was security. I mean, I knew a little bit about both, but I hadn't done a major project in that space. So I learned a hell of a lot on that project. And I ended up actually spending the next 20 years doing projects around those two spaces. They were both relatively new at the time, web security in particular. So I started the startup in that, which actually turns out it got bought last year by Capita. So unfortunately, I sold out too early, but these things happen. And then I got sidetracked into VoIP, voice over IP, and spent a ridiculous amount of time in that space doing telephony in the browser for no particularly clear reason except that it seemed like fun. And I sold that to a company in the States, Troppo, who then got bought by Cisco. So, you know, it's kind of interesting. But that was around WebRTC. And so I kind of looked around after I'd done that, done my earn out with them, and I'm thinking, well, you know, what do I do next? And I stumbled across this. And actually, this is nice. This is February 2016. A German makes a joke about the S in IoT stands for security, except that he says it in German, which amused me. But I thought, actually, this is all dreadfully familiar. And I couldn't work out why. And then it came to me that actually this thing, this is a Zixel voice over IP phone, is my first IoT device. Like, it's internet connected. It's a physical device whose functionality is enhanced by being connected to the internet. It has a minimal GUI, it has almost no keyboard, a couple of sensors, and it improved on an existing thing. So I kind of looked at that, and I wondered whether the problems that we saw in that world 10 years ago plus might be cropping up in this space, and whether the solutions were related, and whether actually 10 years of knowledge was going to waste. And the conclusion was absolutely. You might not believe me, but so that is the configuration screen for a Zixel, for that VoIP phone. Hideous thing, recommends default passwords. You set up a Wi-Fi hotspot, you join it, you do. It's exactly like how you manage stuff now today on the IoT. Like, so it's a dreadfully similar thing. This is a Honeywell thermostat where you have to type your MAC address in. It's exactly the same experience. And what that means is that users just keep the defaults. You all know that, but it's kind of important to see that the similarities are there. And the same thing with open ports. You know, this guy wanders into his architecture office in San Francisco one morning and finds that his telephone, so his PBX has run up a $166,000 bill because there were some ports open and some hackers have gone in and spent his money with the phone system and run premium rate lines or whatever and run off with his money. You'd think we'd have learned from that, but obviously not. This, I don't know if I hope you've all seen this. This is a thing of absolute majesty. This is, it's literally a pirate treasure map. It's, somebody put a skin on top of Shodan, which is the IoT scanning platform, that looked for a specific satellite uplink system that expensive yachts tend to use, that has that's vulnerable to external attack on the remote admin interface, and the remote admin interface, bless it, gives the GPS coordinates. So this is literally all the places where expensive yachts are currently moored, and you could do that as an interactive map. And there's no point in thinking that it won't be found. I mean, in the IoT, in the voice over IP world, we had the experience that at any point when you connected the PBX to the internet, it would be attacked within 10 or 15 minutes typically by this thing, SIP-Vicious, the friendly scanner. Same is now true of not attacked, but visited by Shodan. You will get indexed, and your grain loader or whatever will appear in this database, and it will be searchable, and people will find it and know what ports are open on it. I think this is a grain loader. It could be a baggage handler, I don't know, but they've got an open VNC connection, so you can see what it's doing. The difference is also, this is nice GUI. That one's much more kind of old school. And then there's this other thing that we learned in the VoIP world, which is that round-tripping through the cloud is unacceptable. If you look at the user's acceptability of voice calls, over 200 milliseconds, the acceptability drops drastically. Same thing, exactly the same thing is true for lighting. You know, if it takes more than 200 milliseconds to flip the lights, then it's going to piss people off. So the lessons we learned in that space, in that 10 years, are about trying to be decently secure, lowering the latency, doing transport security, minimizing an attack surface, no open ports ideally, and trying to use standard protocols and known crypto, because every time anyone makes things up, generally they get it wrong. So my contention, and this is kind of the only really contentious piece of this talk, is that those lessons were best learned and best exemplified in this slightly arcane protocol or standard called WebRTC. So WebRTC was an effort by the IETF and the W3C to produce a set of APIs and standards and protocols that would allow you to build Skype in a browser. That was kind of the meta rules, the design goal. But detailed design came out with something that they wanted to be able to do it P2P. They wanted it to be able to be decentralized. They wanted it to be web-based, obviously, and real-time, because you need that. They wanted voice video, and actually we managed to persuade them to add data into that, because we felt that data alongside the call was essential. And the net result is that it's in every browser now. Literally more than 2 billion endpoints sitting there run WebRTC at the moment, which provides peer-to-peer, end-to-end strong cryptography, which is kind of interesting. Open source implementations had to be available, and one of the things that we did in the standards making exercise is to say, we're not going to specify the signaling, we're not going to specify the identity, because we don't understand everybody's use cases, so we shouldn't try and tie them down. We provide tools to let them do it, but we won't specify how they're done. And as I said, it's W3C IETF standard, backed by Google, Mozilla, AT&T, Cisco, God knows who. And very quick kind of overview of how it looks. Basically, you have a device and a device. They meet through a rendezvous service, and they then establish a direct connection that's end-to-end encrypted between them. So the cloud service doesn't necessarily see the content. It's based on this protocol soup of pre-existing, mostly, protocols that do, so stun lets you find your IP address, lets the device find what its own external IP address is. ICE allows two devices to find a path between them through NAT. And that works an amazing percentage of the time. Something like 85% of the time, you can find a path through two NATs without going through a central server. Remaining 15% of the time, you end up needing to use turn, which basically just reflects some packets in the middle. And then once you've got this path between the two end-to-end endpoints, you run DTLS over them, which gives you encryption, but it also gives you at least a hook onto identity, because you're using, in this case, self-signed X509s at the end, at each end, that could be verified. And then on top of that, to make a decent application layer, bizarrely, they chose to run SCTP, which is a protocol that's pretty much only used in diameter and a few kind of obscure telco environments. But basically, it's a really nice protocol in terms of, it's like, kind of think of it as like TCP, but with some UDP aspects, and proper multiplexing. So basically, you can run multiple data streams over TTLS, both ordered and unordered. And then if you actually want to run media, there's a specific media protocol, SRTP, which is kind of used for all of the VoIP phones. And there's this concept of continuing consent, which basically means if you shut your laptop with the browser still open, then the far end can tell after a few seconds and will stop throwing 2 megabits of video data at it because it knows that it's no longer got consent to send. It's reasonably well documented. It's implementable from the standards, which is always a good thing. And so you look at that, and then you look at the goals for IoT, and there are a lot of them are very similar, with the exception pretty much of the identity management, which WebRTC said, well, we'll leave you some hooks, but we won't do the work, but we'll not actually go there, whereas IoT, you need to get there. But the rest of the standards are actually pretty much the same. So then you ask yourself, is this applicable to the IoT space? And the answer is yes, in my contention. So a little diversion here about how IoT is done. Let's take the cameras as an example. Typically what people do is to architect cheap cameras as a server. So the thing just runs as an HTTP server. It's really cheap for the vendor. And you punch a hole in the local router, or you put it on DMZ, and it's then visible to the user who logs in over some relatively insecure username and password combination and gets at it. And it's quite hard to encrypt that because you can't put a certificate on there because you don't have a fixed IP address and you don't have a domain name. So it's a little bit insecure, but if you're on the LAN, it's super quick and it's super efficient. So that's a kind of server type model. And if you think about the way that the current best practice is, that is a much more client model, that both the user and the device are clients to a cloud service, and the cloud service joins up the two entities, routes the data between them. Downside of that is typically the cloud server can see the data and is therefore, come the GDPR, responsible for it, which is kind of interesting. Do you want to be responsible for that data? Not so much these days. And anyway, you'll have to pay for it, because at least one of those legs is going through the cloud, so you're going to have to pay for that somewhere. And then the other thing is, well, you know, you're holding the auth as well, so you're now a honeypot for attack. And it's not a perfect architecture from latency point of view either. So there's big downsides for this, particularly in the webcam environment, for doing this kind of environment. What you really want is a mix between the two, or in fact, what we had in the VoIP world, which is essentially peer-to-peer. You want both ends to be peers who can find each other through a cloud-based rendezvous service, but once they've done that, it steps out, it doesn't hold the auth is held at the endpoints, you get lower latency, and using the right protocols, you can get rid of both the passwords, but also ports. You can close all the ports, so you don't have the thing scanned and attackable in that way. Which brings me to pipe. So this is what I've spent the last 2 years building, experimenting with. So pipe is essentially based on WebRTC, and it brings you a zero install client on all of the browsers, which is kind of nice, because the browsers, I just load the JavaScript. And the identity is managed by self-signed local X509s. And the identity is verified by proximity, either by QR or Bluetooth LE. So when you first get the box, switch it on, you claim ownership of it with your phone, and then from then on it knows that it's yours. That's based on some work that, loosely, based on some work that Ross Anderson did in the 90s, called the Resurrected, you can look this up, it's a nice paper, it's called, I think, the Resurrected Duckling Protocol. And it's basically about the idea of trust on first use. And allegedly ducklings trust the first thing they see. They think that's their mother. Actually, we flip this around, and what we do is we have the device showing a QR code, which you scan with your phone. And then it connects, verifies that it's got the random data as well, and then that proves that you are the owner. I can show you this, I think, show you this somehow. Like that, maybe. And if it, yeah, it does work. I was going to say if it doesn't work, you can come see it done upstairs.
So I'm going to show you how pipe can be used to pair a IoT device with a smartphone. So what we have here is a IoT device that runs the pipe code. And what happens is that when you first get a device like that, and you first power it on, it shows you a QR code, which allows you to claim that device using a web browser. So in the web browser here on my smartphone, on my Android phone, I'm going to go to the claim page and then show it this QR code. Now the two of them now exchange cryptographic keys, and they now recognize each other. They have done a key exchange and they recognize each other. And that's not through a third-party authentication service, and you'll notice there are no passwords used. It's simply that I was in proximity with the device when I first switched it on, and that I could therefore read the QR code. So now we have these two recognizing each other in a cryptographically strong way, and through a protocol that will find its way through the internet. So this device is on 4G and that's on Wi-Fi, and now I can look at, say, the CPU temperature on that device. So I go to the correct page on my website and browse, select the device that I want to monitor the temperature of, and there we go, we get the reading. Now, what's nice about this is that, as I said, it forms a secure connection.
Yeah, heard enough of me. Well, I have anyway. You get some more. So let me see, how do I get back to here? Probably. Yes. So that pairing, quick, full X509, decentralized X509 exchange, over end-to-end encrypted link verified by an out-of-band token. And you only do that once. Like, that's the first time only. From then on, it persistently stores that token and that identity. And you can extend it to lend and borrow. I can lend a device to somebody else and they can use it. The trick here, and this is the kind of interesting stuff that we came up with, is the idea that if you use the fingerprint as an address, like, so basically each endpoint creates a public-private key pair, and then it uses the hash of that, self-signs it, then it uses the hash of that as what you could think of as an address or an ID into a peer-to-peer virtual mesh over the IP infrastructure, and then run DTLS over it, verified by that key pair. That gives you a set of really nice properties. You get the mathematical near certainty that any endpoint will generate a unique identity in that mesh, which means that if I buy a washing machine from Bosch and a webcam from Siemens, I can guarantee that their IDs will be compatible but not overlapping, which is kind of nice. The endpoints can instantly know the provenance of incoming requests because they're all effectively signed by the keys, which means that you can just drop the DTLS hello. If it's not from a friend, you just drop it. There's no need to process that packet beyond being able to read who it's from, which is nice. Endpoints are their own auth servers, which means that you don't need a central authority. In strong contrast to the Intel presentation, which is a very centralized story, this is totally decentralized. Now, I agree there are places for both, and in fact, a good architecture ends up doing both things. But I wanted to emphasize the decentralized aspect. Using the hash as an ID means that we only actually need 32 bytes over a trusted channel to extend the web of trust another step, which means that we can do it over things like QR codes, Bluetooth LE beacons, and anything else where you can squeeze 32 bytes over a channel that you can rely on. Everyone always asks what cipher suites we support, so that's the page. Basically, this is the preferred list from Chrome. That's what we support, and we'll continue to do that. So what we end up with over this is a data channel, the WebRTC data channel, which is end-to-end encrypted. And it has a nice property of being able to do named channels over it, so it's multiplexed, over a single port pair, and those channels are bidirectional. You can select whether you want reliable or unreliable. You can select whether you want enforced ordering or not. And all of those are just simple properties of setting the channel up. You get zero round-trip creation of these channels, so they're cheap. Once you've got a pairing, you can create channels very cheaply, which is nice. And the API looks like a WebSocket, so your web developers will like it. This is what it looks like. This is how you set up and connect and get pages from my camera. It's a nice, simple piece of JavaScript. What does the user need? Well, any of these things: iOS, Android, Safari, Chrome, Firefox. Not actually Edge yet, but soon. It's in the standard. They just haven't implemented it yet. And at the other end, we need a small ARM Linux. So BeagleBone Pocket, that kind of device. And it runs our stack on that device. So we've implemented a lightweight version of WebRTC. So we built a few things. Now, we're working with customers who won't let us talk. So all of the really interesting examples, I can't talk about. I said this to a friend of mine the other day. He said, yeah, welcome to the embedded world. It takes 3 years before you can talk about the things you've been doing, which is frustrating. But because the web world, we publish instantly, you know. So anyway, these are actually things that we built as proof of concept for our own amusement rather than, and as demonstrators rather than as commercial products. So the first one's a webcam, and most of them are working upstairs on the demo, so if you play with it, you want to. This is just a basic test of pairing, supports lend and borrow, no passwords, no open ports, and roughly 85% bandwidth over a typical cloud solution. And that's running on a Pi 3. This is the doorbell. Quite fond of this. We use Bluetooth LE for pairing, so it's actually an exercise in working out how to do Bluetooth LE. And you could think of it as a range extender for Bluetooth LE in a sense, because you do a pairing, and then once you've paired over Bluetooth LE, that pairing kind of sticks over the whole internet, which is kind of nice. There's an interesting side thing here. How do you set up something with only one button and no screen? How do you get it onto the Wi-Fi? How do you configure it? Which turns out, actually, the answer is IVR is a really nice way to do it. I shall show you that in a minute. And then, of course, it being a doorbell, it's more like an entry phone in the way, in that you want to be able to talk to it and you want to see who's at the door. We did that on a Raspberry Pi Zero W, and again, that's upstairs, although I don't think it's working, actually. So IVR for doorbells. Turns out this is actually a really nice way of configuring a doorbell. My friend Alison at the IVR Voice recorded these for me, not wholly seriously, I think.
Hello, I am your pipe-connected doorbell. Once I'm set up and paired with your smartphone, you'll be able to use it to speak with visitors at your door from wherever you are, home or away.
So this is the kind of, you plug the thing in and it talks you through the setup.
I need to be connected to your Wi-Fi and paired with your Android smartphone. You can use the Nearby app on your smartphone to get started. Great, now I'm securely connected to the internet. Trying to whisper sweet nothings to your phone.
So this is the point at which you do the pairing.
Your smartphone and I are now best buddies.
There you go, so pairing's worked.
Your phone now will ask you to accept notifications from me, which I'll send when someone presses my button.
This is the point when you get nagged for agreement on the Android screen. So we thought we'd try and make that a little bit kind of light.
Your phone will also ask you to allow me access to the microphone. I'll only use that when you press the answer door button. Ding dong!
There you go. You see, so IVR isn't irrelevant in the new world. We did a meeting room presenter as well. So the idea is that one of these screens would just basically have a Raspberry Pi sitting next to it permanently. When you come into a room, it'll have a QR code on it, you scan it, you get a short-term pairing with it, and you can screencast from your phone to the device. You can use, this would be on, Ethernet presumably, and your device would be on 4G or Wi-Fi. and they'll just talk over that. No state is left on this device, so your slides don't get left here, your identity don't get left here. We've done that with a BeagleBone and a Pi 3. This is lovely. This thing, this friend of mine does interactive sculptures, and so you wanted to publicly control. This is about 3.5 meters tall, and it's sitting, or it was sitting in Reno in public interaction, and all of those 500 LEDs twinkle. And I actually needed to remotely maintain it from here, so we used the pipe stuff to be able to connect in and make the artistic changes that were demanded by the artist, which actually turns out to be what happens. And then the other thing is that it tended to get moved around, and you'd find a totally new network connection. But with the way that the pipe network does a virtual mesh over an existing network, kind of doesn't matter. It'll find itself. So again, that's a BeagleBone Black. This is an interesting project that's in progress at the moment, which is there are quite a lot of IoT devices out there that offer a local web interface over the Wi-Fi that's horrendously insecure if you export it beyond your Wi-Fi. So what this does is you put a pipe layer in, which then proxies that only out to trusted devices. And the cute thing is that you can do that without running a proxy receiver on the far end. Like the Chrome in particular is now powerful enough that I can receive those proxied pages and display them to the user as if they were real pages, and you can't tell, or pretty much can't tell, which is interesting because it minimizes the amount of changes you have to make to the device. We're working on this with a few companies I can't talk about, but we've done a mock-up with OpenHab just to see how it would play out. Again, that will run on a BeagleBone Pocket, which is 18 euros, I think. This one's totally the other end of the scale. This is about how to do narrowband IoT or 2G end-to-end encryption. How to do low impact end-to-end encryption in that environment. It's basically the same thing. I've got your font problem here. It's basically the same thing. You set up an end-to-end encrypted, think of it maybe as a little bit like a VPN, only the devices can't talk to each other. But the difference here is that the data may end up in a database here rather than going out to the endpoints. This end may be a data center, a customer data center, rather than necessarily out onto the devices. And we can support that as well. So that's active development at the moment. We haven't, it's not a product yet. This is a thing I built entirely for my own amusement. Well, no. I have an elderly relative who's getting a little Vega, as we all are. And the idea with this is that it will play a podcast. You switch it on, and it will play the current podcast from a set of 5 or 6 podcasts. And you just whack the button if you're bored with this, you don't want to hear whatever it is, another episode of The Archers, you've had enough of that. You just whack the button, and it'll play the next podcast. Nice thing for people who, really don't want hugely complicated interfaces, but do want to listen to their choice of radio when they choose to. But the thing is, how do you update that list? How do you put a new thing on it? And the idea is you don't want to put a screen on it, you don't kind of want to make it complicated. The idea is that I, as the father and the son-in-law or whatever, will log in remotely over pipe, update the list, push a new set and use it. Interesting experience. I did it with the Google AI kit because that's a really nice speaker, and it's quite a cheap way of getting a nice speaker. So my summary here is there are a lot of lessons from the voice over IP world that are applicable to IoT, and particularly distributed IoT, decentralized IoT, because that's essentially what we've done in telephony. We've managed to build a pretty heavily decentralized cooperative network. And I think we can learn a lot from that. We're using the WebRTC data channel in particular, because I think that's a really nice protocol. And this is my ask for this crew, this place. I mean, this is great, but when you start drilling down into concrete requirements, I think it's too early to start standardizing on the cloud being the right answer. I loved your quote about what we've learned in in the data center isn't necessarily relevant out in the IoT world. I think that's exactly true, and it's also true for standards. I think we need to be quite careful about standardizing too early in that environment. I've got some of these proof of concepts upstairs. You're very welcome to come and play with them, hopefully they'll work. And I'm looking for investors and paid proof of concepts. So if you've got something you want built and you're prepared to pay a little bit for it, that's great. If you've got some money you want to invest in this space, even better. Love to talk to you. And questions, if anyone has.